Hello everyone, my name is I Lakshmi Nivas and my ID number is 21951A0588 and I'm from CSC B section and the subject of the Tech Talk PPT is Applied Physics, and today my topic is on the way to quantum based satellite communication. So let's discuss about it. So on the way to quantum based satellite communication. So coming to the abstract, quantum mechanics based techniques are receiving much interest from engineers. Although a working quantum computer is still a promising tool of the far future, there are many different quantum algorithms and protocols that can be used in communication to exploit the advantages of free space quantum channels. It will be necessary to use space and satellite technology. Introduction. Since the first orbit of the Sputnik satellite in 1957, thousands of satellites have been launched. More than 55 years after the start of the space age, we use many applications that are based on the satellites, such as weather forecast, global navigation, remote sensing, emergency alert systems, and telecommunication. Satellite communication has been used for many years and we know its limits. We need bandwidth with higher efficiency and safe and private communication. Quantum computing is based on various quantum effects and offer solutions for different problems such as prime factorization, searching in unsorted databases, key distributions, and information coding. An important communication question is how a secret key can be distributed among the communication parties. Quantum key distribution, QKD called simply, offers a secure solution for this problem. So coming to this is the picture of a quantum bit processor. This is how it looks like. In quantum bit processor applications, different polarization of photons represents the quantum states. The space of quantum bits, qubits, which are called as qubits, is continuous, and the unitary transformations applied on qubits are continuous as well. These unitary quantum transformations have finite precision, and to realize an idealistic channel, the qubits have to be isolated from the environment. However, in the practical implementations, this isolation cannot be perfect since we would like to interact with the qubits. So these are how the qubits looks like in the right side image. One of the primary requirements of free space quantum communications is capability to effectively transmit quantum states in noisy environments. Due to the lack of efficient quantum repeaters, fiber-based optical QKT is limited to a distance of approximately 100 kilometers. However, free space quantum cryptography makes the transmission of photons over long distances possible. Free space quantum communications can be extended to ground satellite or satellite to satellite quantum communication, which could be an ideal application for the global QKD. Coming to the quantum key distribution, quantum cryptography. Quantum key distribution was introduced in mid-1980s as a method for generating shared secret random number sequences for cryptographic keys. One efficient classical encryption method is public key cryptography, which uses different keys for encoding and decoding. One efficient classical encryption method is public key cryptography, which uses different keys for encoding and decoding. The Rivest, Shamir, and Adelman RSA algorithm uses the product of two large prime numbers, and it cannot be encrypted without the knowledge of the prime factors if the public key is large enough. Its safety is based on the fact that factoring is a hard problem with present computational power. Quantum key distribution. However, the quantum Shor algorithm can break RSA in just few seconds. From a practical point of view, RSA will be broken when quantum computers are built that can use a high enough number of quantum bits. So this is how a QKD system looks like. It has an two encryptors, and Alice and Bob are two communicating systems, and there will be a channel in between them for communication through the help of photons, which carry out the information and secret codes and keys with each other. So transmission of classical information through the quantum satellite quantum channel. Since the QKD protocols follow the laws of quantum mechanics, including the no cloning theorem. A brief characterization of selected QKD protocols. The BB84 protocol uses two bases with two orthogonal photon polarizations each. All four polarization states are not mutually orthogonal and, according to the laws of quantum mechanics, not perfectly distinguishable from one another unless additional information is known about to which basis they belong. The strength of this protocol is that the quantum communication takes part only in one way, and this is useful since it generally means fewer errors in communication, and for ground satellite channels where uplinks tend to have greater losses, the more efficient downlinks can be used instead. The weakness of the protocol is at least 50% of the quantum bits are inherently lost since both Alice and Bob are using random bases. E91 is based on the properties of the entanglement. During the initialization phase, entangled pairs are shared between Alice and Bob. The B92 protocol is similar to BB84, but only two orthogonal states of the four possible BB84 states are used. It is impossible to identify the qubit with 100% probability since no measurement can be distinguished non-orthogonal states. The B92 protocol is similar to B84, but only two non-orthogonal states of the four possible BB84 states are used. It is impossible to identify the qubit with 100% probability since no measurement can distinguish non-orthogonal states. The S09 protocol uses the same basis and polarization states as the BB84. After Alice chooses a string of random bases and sends Bob photons with polarizations corresponding to those bases, Bob sends them back to Alice while randomly changing some of the photons. Polarization using two different quantum logic gates. The gates can be used without any knowledge of the original polarization, and they have preserved the base. Quantum-based satellite communication, general free space quantum channel. So this is again a QKD system with combination of Bob and Alice with two encryptors, and the communication happens with the help of photon exchange. General free space quantum channel. The wired or free space quantum channel is a communication channel that can transmit classical and quantum information. The transmission of classical information over a satellite quantum channel between the sender of Alice and the receiver like Bob is illustrated in the above figure. The first and last boxes are abstract boxes that represent classical transformations in the earlier image. The other boxes, except the measurement, represent unitary transformations built from different quantum gates that will be performed on the input qubits. The communication starts with classical information at Alice's side. Procedure. How does it happen? The abstract box marked A in the figure represents the classical procedures that were performed by Alice to produce her initial classical state, which needs to be sent through the quantum channel. The sender classical information is encoded into a quantum state using two transformations. One of these transforms the classical bits into quantum bits, the box marked with that symbol AC. And the other one marked C transforms the initial quantum bits. The classical analog is the source coding and channel coding. In this term, box A is a classical quantum converter. Similar to classical analog digital converter, its main task is to produce a quantum bit in the function of initial classical bit. For example, one possible conversion is to code initial 0 into 0 and classical 1 into 1. Box C performs further transformations on the initial qubits. The encoded quantum states are sent over the satellite quantum channel. The errors appearing in the quantum channel are different from the errors of the classical channels. The system is in contact with the environment, so the system and the environment together form a closed quantum system. This means that the reason for the noise is the uncertainty in the channel. So the noise is the result of the interacting with environment because of the non-ideal environment. Bob receives a damaged state due to the channel error. In the decoding phase, Bob performs quantum transformations on his qubit, which has marked D, and finally measures it. According to figure 1, transmission of classical information through the quantum satellite quantum channel. A, B, AI, BI, A, C, DC, classical input, classical output, classical domain, C/Q encoding, decoding, measurement, quantum channel, quantum domain. Alice Bob meeting in person might be expensive as well as infeasible. Several classical algorithms exist for secret key exchange, but the secure way offered by quantum approaches is based on the laws of physics. Possible configurations of QKD in satellite communication. So this is how three types of communications are done. One is from Alice to Bob, and other one Alice to Bob and Bob to Alice, and one is from two satellites, which is Alice to Bob, Bob and Alice, which are both are the satellites together, and Alice in the third one is a ground station, and Bob is also a ground station. From Bob to Alice, the network or the information is passed through single satellite, which can be done through QKD in satellite communications. So this is how the possible configurations for QKD in satellite communication. QKD in satellite communication. Quantum key distribution uses individual light quanta in quantum superposition states to guarantee unconditional communication security between distant parties. However, the distance over which QKD is achievable has been limited to a few hundred kilometers owing to the channel loss that occurs when using optical fibers or terrestrial free space that exponentially reduces the photon transmission rate. Satellite-based QKD has the potential to help to establish a global scale quantum network. Owing to the negligible photon loss and decoherence experienced in empty space, here we report the development and launch of low Earth orbit satellite for implementing decoy state QKD, a form of QKD that uses weak coherent pulses at high channel loss and is secure because photon number splitting eavesdropping can be detected. We achieve a kilohertz key rate from the satellite to the ground over a distance of up to 1200 kilometers. This key rate is around 220 orders of magnitudes greater than the expected using an optical fiber of the same length. The establishment of a reliable and efficient space to ground link for quantum state transmission paves the way to global scale quantum networks. This is how QKD in satellite communication works. Communication schemes. So schemes of communication. Future free space QKD applications can include direct communication among satellites, where the secret quantum key exchange process will be achieved between satellites on low, medium, and geostationary Earth's orbit, which means low Earth orbit, which is LEO, is 300 to 2000 kilometers, and middle Earth orbit, which is MEO, is 2000 to 35,000 kilometers, and geostationary orbit, which is GEO, is approximately 35,786 kilometers with an inclination of 0 degrees. The QKD and other quantum computing algorithms can be used in the following three scenarios, which are open air or free space communication is communication between two entities of the ground, which is example two antenna towers. As we have seen earlier, Alice and Bob's are two antenna towers, and with one single satellite, the communication happened between them. In this case, no satellite is involved, but this scenario needs to be mentioned as we can gain such useful channel models by experimenting in this environment. Satellite to satellite communication, where two satellites transmit data to each other, can be implemented between any two satellites that are in line of sight of each other. Ground satellite or satellite ground communication happens when one party is satellite and the other is ground station. As we have seen in the earlier this image, we can see that all three methods are there in this slide. So these are the communication schemes. QKD in satellite communication. So Future satellite QKD schemes can be applied in 3 schemes. 1. Simultaneous key generation between ground stations using an EPR based QKD scheme. 2. Global QKD based on satellite ground quantum communication, sharing keys between ground station and satellites. 3. Global QKD based on ground satellite and satellite ground communication, sharing keys between ground stations via one or more satellites. So this is how the image looks like. Satellite payload, which is a transmitter. So let's go to the next slide. Graph for clear visibility in weather by QKD. This is the graph which represents the clear visibility in weather for transmission through QKD process. So transmittances in ground satellite. The first graph shows that transmittances in ground satellite. The second graph B shows that satellite ground quantum communication in a tropical climate. Horizontally, the zenith angle in degrees and vertically the transmittance are illustrated. Labels over the graph indicate Bob's detector diameter in meters. Alice aperture is 0.2 m. As we can see in first A and B graphs, we can see the diameter of Alice, which is 0.2 m. The satellite is orbiting at 300 kilometer height, and clear weather means visibility of 23 kilometers. So these are the situation for the graph for clear visibility in weather by QKD. There are 3 types of communication services that satellites provide. One is telecommunication. So what is telecommunication? Telecommunications, also known as telecom, is the exchange of information over significant distances by electronic means and refer to all types of voice, data and video transmissions. So this is how telecommunication works. As we have an example, which is 5G, 4G, 3G and 2G and 1G, which are the important keys which play a major role in telecommunications nowadays. To broadcasting. What is broadcasting? Broadcasting is the distribution of audio or video content to a dispersed audience via any electronic mass communication medium, but typically one using the electromagnetic spectrum in a one-to-many model. So broadcasting is the best example is cable connection. We get to see all the TV channels and programs through only broadcasting this one-to-many model satellite electromagnetic spectrum. So this is how the broadcasting works. 3, which is data communications. Data transmissions and data reception, or more broadly data communication or digital communications, is the transfer and reception of data in the form of digital bit stream or a digitized analog signal over a point-to-point or point-to-multi-point communication channel. So this is how the data communication looks like. It is stored in supercomputers, which are a heavy, very big computers which stores a lot of data. So from sender to receiver, the messages are sent in a specific protocols. Even protocols are maintained to send to send or interact the messages between 2 persons, which is from sender and to receiver through a transmission medium. Thank you. This is all my PPT. Thank you for attention.